back to Math 155, section 9.2. In this lecture video, let's take a look at what we so-called the compound interest. All right, compound interest is the most fundamental or basic formula for investing. Okay, investment, like we put our money into a particular money market account or the CDs at the bank or the savings account. All right, then the way how the money is growing is by the concept of a compound interest. Basically, the concept is, imagine if you have a small snowball on the top of the hill. As you're rolling down the hill, the snowball will get bigger and bigger and bigger. Okay, it's basically an exponential explosion on the money that you're investing. All right. So compound interest is the interest that is computed based on both the principal and the accrued interest as additional principal at each interval. So what that means is, as a snowball rolling down, the original ball is still there, but as we're picking up more snows, that ball gets bigger and bigger and bigger quicker. So in terms of a compound interest, it's basically taking the principal, the money you're investing the first time, and then add on to the interest that you earn on after so long you put in the account. So you have a principal plus the interest from the first period of compounding, and then use all those money and take them into computation into the next compound interval. All right. So here is our formula: A equal to P times parenthesis 1 plus R over N, whole thing raised to the N times T power. So P is representing the money you are investing. R is your interest rate. Lowercase n representing the time period that you are compounding. So whenever you see compounded annually, that means this account, okay, only it's almost like a snowball, only roll over one time in a year. All right, it's always by the year. Semi-annually means it's like my snowball only roll over 2 times in 1 year. Quarterly will be 4 times in a year. Monthly is n is 12. Daily means I'm compounding 365 times in a year. All right, so this interval thing, okay, that we're talking about is your compounding period. How many times does the account roll over? Each time it roll over, it takes the principal you had in your account plus the interest. So all that money, take them into the next compounding period to generate more and more money. That's the reason why I mentioned that compound interest is basically taking your money, okay, and make an exponential explosion on it so you can earn even more money. All right, so last time in the last video, we hear the word called the future value. Capital letter A stands for future value. So in terms of investment, future value representing how much money is in your account after so long. When it comes to borrow money, okay, then the future value representing how much money do you need to pay people back. Okay, so there's two different ways how we use the word future value. So for right now, our future value representing the amount of money that will be in our account after so long we invested. Now, we are not going to do any problem. I'm not going to do any problem regarding to something called a continuous compound interest formula. Basically, the continuous compound interest formula is referring to the future value A, how much money is in your account, okay, it's basically continuously being compounded. It's not like compounding once a year, okay, it's not like twice a year. Continuous compound is basically, imagine a snowball just keep on rolling, never stops, okay. It's not saying one time in a year, just keep on rolling down the hill, okay, however the long the hill is going downward. Okay, if we continuously compounding our money will grow bigger and bigger and bigger fairly quickly. All right, so let's do a couple of examples. Let me show you how to use the compound interest formula real quick. All right, so I'm going to write down my formula here in a few minutes. Suppose that $14,000 is the deposit for 6 years. So that's my time. At 5% APR. So APR here is basically my R. Calculate the interest. Okay, this is asking for the interest. Calculate the interest earned if interest is compounded quarterly. So whenever you hear the word compounded, that means we got to use the compound interest formula. R over N holding to the N times T power. All right, then when you hear the word quarterly, that means my N is equal to 4. All right. So this capital letter A representing how much money will be in my account after 6 years. So P, 14,000. I put $14,000 in this account times 1 plus my R is at 5%, 0.05, divided by compounding 4 times in a year. This my N. Whole thing raised into my N is 4 times time, which is 6 years. So if you think about it, this 4 times 6 is 24. That 24 representing this account will actually compound 24 times before this will compound 24 times total during that 6 years. Okay, so it will actually take the principal plus the interest, keep on using that same, using those money in the account, keep on rolling over. Okay, so basically, let me write it down here just a couple times. Okay, all right. First year we will compound 4 times. So the very first time we compounding, that's actually taking $14,000 using simple interest formula times 0.05 times 1. 4 times in a year, that means every 4 times in a year, so that will be every 3 months out of 12 months. Let me do this real quick. 14,000 times 0.05 times a quarter, which is actually 0.25, excuse me. So at the end of the first 3 months, my interest is 175. So rolling over means now I'm going to take my 14,000 plus the interest I earned and go into my second time that I'm going to do this computation, which will give me $14,175 times, all right, my interest rate 0.05 times my time, which is another 3 months out of 12 months in a year. So at the end of second time, I'm calculating my interest. See, I'm using 14,175 rather than just 14,000 now. So now my second time, the interest will be slightly higher. Which will earn me 177.19. So rolling over again means take my $1,475 that was in my account, add on another 177 plus 0.19. So now at the end of the second time, I should have $14,352 in my account. Take that money, do the same computation again. So every time when I say roll over, this is what's going on mathematically. All right. So rather than do this 24 different times, it's just easier. We just use the formula. So basically, the formula says take 14,000 times parenthesis 1 plus 0.05 divided by 4. Then whole thing raising to, if you want the calculator to do the exponent for you, then what you can do is put 4 times 6 in the parenthesis. 4 times 6 in the parenthesis, okay? Be careful now. My calculator, after I key in the caret key for exponent, after that, I have to open the parentheses. So if you ever have, if your calculator look like this with a little box up here, you type in 4 times 6, you don't need a parenthesis. It just, you need to realize that after you type in a 6, you need to press the right arrow key to move the cursor downward. Otherwise, the cursor stays on top. Okay, just be careful with that. So at the end of the 6 years, which is compounding 24 different times, I should have 18,862. 18,862 and 91 cents in my account. Okay, that's how much money I will have in my account. All right, after the 6 years. Compound interest. So I'm not quite done yet. This problem is asking for the interest earned. So inside this $18,000 is actually have my principal, $14,000 that I put into this account, plus the interest, okay, that you accumulated. So to extract the interest, I need to subtract from the 18,000. So how much interest did this account just make me? Minus 14,000. So 6 years later, I just made $4,862.91. All right, that's what that means. Doesn't seem like a lot of money. Is probably because the interest rate R is actually not that big. Okay, because if I will have higher interest rate R, maybe like a 10%, that will definitely earn me a lot more money. Oh, let me just play with this. So let's pretend, okay, let's pretend this problem actually says compounded continuously, okay? If I do continuous compound interest, just put my P right there, 14,000, times this thing called the E, the number E, which is second e to the x power, and I'm typing R is 0.05 times 6. So if this account continuously compounding, okay, I will slightly get a little bit more than compounded 4 times in a year. Okay, not a lot of money because the interest rate R is not that high. All right, so this one, same thing. Couple deposit $22,000 into this account, earning 7%. I'm gonna put this money away for the next 20 years. Calculate the future value. So this problem is asking for the future value. That means asking for how much money would it be in the account after 20 years. All right, and the problem says we're gonna compound. So when you see that word compound, you use the compound interest formula. Daily means N is actually going to be 365, okay? Compounding 365 days in a year. So A equal to principal times 1 plus R over N, whole thing to the N times T power. So let me write this out and we can put in the calculator together. 7%, 0.07 divided by N. N is 365. When you see daily, that means we're compounding 365 times in 1 year, raising to the N times T. N is 365 times T, 20 years. So times 20. So I'm going to let the calculator do the 365 times 20 for me, okay? So let's see how much money will be in our account after 20 years. 0.07 divided by 365, raised into the parenthesis 365 times 20. So after 20 years, $22,000 grow into $89,202. All right, and 42 cents. Well, you might ask, well, that's a lot, that's a long time. Okay, that's a long time just for $89,000. Well, that is true, but think of this way. This is $22,000 that we put in the account for 20 years. So we never went back to add any more money to the $22,000. So what these type of problem is saying is, if you put this money aside and never touched it for the next 20 years, okay, then if we never add anything to it, then it don't grow as big as what you want to. So normally when it comes to people think about retirement. When it comes to retirement, you pay into your retirement every time you get paid, because when you keep on putting money in there, okay, every month or every 2 weeks, the principal, the P, you're constantly adding more principal to your account. So of course, during the working years, of course, that thing is going to grow exponentially. But this particular example is saying we never add any more money for the next 20 years. Then 22 grand becomes almost $90,000. Okay, so it's not a bad trade-off. Doesn't seem like a lot of money, but you got to think about we never actually put any more money into it. It's almost like planting a tree and never watered it for 20 years. So of course it's not going to grow as big as you want it to. So think of it, every time when you put money into your retirement, it's like putting down some fertilizer, into your plant to help it grow bigger and stronger over the years. All right, let's take a look at this one real quick. Suppose your salary in 2013 is $75,000. Now, there's an annual inflation. So whenever you see the word inflation, you think about compound interest formula. Inflation is calculated once a year. So that means in my compound interest formula, the n got to equal to 1. Okay, the n will be 1 because inflation is calculated once in a year. So let's say if the inflation rate is at 6%, what salary do you need to make in 2022 in order to keep up with the inflation? So this is an example of what we so-called the cost of living increase. Because if you're making $75,000 and then when you retired, after all those years, still making the same amount of money, you're actually losing money. You're not keeping up with the cost of living. Okay? So that's the reason why a company periodically will give you a raise due to the cost of living. All right. So let's see. 2022 is how many years later compared to 2013? So remember now, every time, year after year, you're not getting a raise due to the inflation, then that means you begin to lose money. $100 today is not quite the same as $100 20 years ago. Okay, what I mean is inflation. So this is 9 years later. So the time is 9 years. All right. So if I say P is 75,000 today, P also representing present value. Today's value is at 75,000 times 1 plus 0.06 divided by 1, raised into the 1 times T, which is 9 years later. Then in the future, let's see, 75,000 times parenthesis 1. Okay, hang on a second. 0.06 divided by 1 is still 0.06. 0.06 plus 1 is 1.06, right? Close parenthesis, whole thing raised into 1 times 9 is 9. So in the future, that $75,000, if we keep up with the inflation 6% per year, I will need to be making $126,710. So sometimes, so what this means is, over time, we got to keep, our pay got to keep up with the inflation. Therefore, is inflation is something that is basically unavoidable. Okay, things is just gonna cost more over time. If you know people that are much older than you, they will be telling you, "Oh man, the gas price used to be 75 cents." Today is like over $2, over $3 sometimes. So that got a lot to do with inflation. Okay, things just go up over time. So we use the compound interest formula for inflation type of problem and also for investment. Okay, so when we use compound interest formula for investment, it's basically an exponential explosion on your money over time. All right, that will conclude this lecture video of compound interest. Thank you for watching.